Good morning to all of you. I welcomes to all in our lecture series on solid state physics. In our last class we have been discussed about half portion of Einstein theory of lattice space heat capacity. Up to this much we have been discussed with step by step up to equation number 6. Today we are going to discuss about high temperature behavior and then low temperature behavior. So up to this much whatever we discussed in our last video, I suggest that you have to go for the last video before you have to watch this video, because this is the half portion we are going to discuss from the half of the portion of the Einstein theory of lattice heat capacity. So here the assumptions whatever the Einstein has been considered, that we have been discussed, and with considering those assumptions, we found that one-dimensional harmonic oscillator internal energy, one-dimensional harmonic oscillator have average internal energy is this much, that is equation number 3, and the total internal energy of crystal having n atom, we found 3 into n into average internal energy of one-dimensional harmonic oscillator, that is equation number 4 that we found. And from this expression we calculated the specific heat capacity of a crystal, and we found this much, which is named as equation number 6. And here theta E we considered as Einstein's temperature, or known as characteristics temperature, that is h cross omega 0 by kb. Okay, here omega 0, here h cross is constant and kb also constant, which is called the Boltzmann constant. This is called the Planck's constant, and omega 0 also will be the constant for a particular material. So now we are going to go for higher temperature behavior by considering this equation number 6. Yes, here as we found that h cross kb omega 0 is the constant, theta e also a constant factor for a particular material. Okay, now we are going to vary this temperature T, higher temperature side, what type of behavior we are going to get the CV of a material. At the lower temperature side, what will be the value or what will be the behavior of the CV of a material, that we are going to be discussed. Okay, first we are going to consider higher temperature behavior. For temperature greater than that of the theta E, now we are going to consider if T is much more greater than that of the theta E, or kBT is greater than that of the h cross omega. That means, see here, if we have to consider this one, that is theta E by T as compared with theta E, if T is greater, then theta E is nothing but how much? H cross omega by kb, right? So T is also greater than that of the h cross omega 0 by kb, or we can write kb into T greater than that of the h cross omega. Okay, now we can write this one. This is e to the power h cross omega 0 by kbt, that means e to the power x minus 1. You just consider e to the power x, this one. So if I am going to expand in the form of e to the power x, then it will be 1 plus x square by 2 factorial, x to the power 4 by 4 factorial, like that. But higher terms we are not going to be consider. If we are going to consider first two terms, we can find 1 plus x means h cross omega 0 by kbt, h cross omega 0 by kbt, plus other terms not to be considered, and this is minus 1, and we can get approximately h cross omega 0 by kbt by neglecting higher terms. So this whole term is will be equivalent to this one if we are going to consider higher temperature. Now we are going to consider equation number 3, that means we are trying to find out the average energy or mean energy of a single one dimensional harmonic oscillator. See, this term here, this term will be equal to this much, h cross omega 0 by kBt at higher temperature. So instead of this term, I am going to be put this much in equation number 3. That means equation number 3 is representing the average mean energy of a one dimensional harmonic oscillator. So the average energy or mean energy will be equal to half h cross omega 0 plus h cross omega 0 by h cross omega 0 by kBt. So here h cross omega 0 h cross omega 0 got cancelled, and we are going to found approximately kBt. This is h will be average energy will be half h cross omega plus this will be kBt, will be approximately kBt, because kBt is greater than that of the h cross omega that we considered. Okay, so this is equation number 7. So average or mean energy of one single harmonic oscillator is, we found kBt. So from equation number 1, it is found that at higher temperature the average vibrational energy is the same as that of the obtained from the classical theory. You just recall the classical theory. Classical theory, how much we found the average energy of a single harmonic oscillator? I am going to show you. See, we found this is the expression of average mean energy, average energy of a single harmonic oscillator. From this expression we found, this is, you can check your notes, we found that this much average energy we found, that is kBt. This is the represent the average energy of each oscillator. That means each harmonic oscillator, one dimensional harmonic oscillator, by considering classical method. And this value is same. This value is the same if we are going to consider Einstein's method at higher temperature. Einstein's method at, or Einstein's model at higher temperature, we found the same value. Only for that I have been written like this. Is the same as that of the obtained from the classical theory. Hence, from equation number 5 we found, from equation number 5, that means equation number 5 is this one. So equation number 5, how it will be modified? See, exponent of h cross omega 0 by kBt minus 1, we have been found how much, h cross omega 0 by kBt. These things I am going to be substituted in equation number 5. So here from equation number 5, it will be modified as 3nkb h cross omega 0 by kBt square into 1 plus h cross omega 0 by kBt by h cross omega 0 by kBt square, because these things, this whole value is considered as h cross omega 0 by kBt, okay, at higher temperature. So it will be, see, this term got cancelled. It will be 3nkb into 1 plus h cross omega 0 by kBt. Okay, so for large value of t, if we have to consider large value of t, then this denominator will be large and this factor will be tends to 0, and we can get Cv equal to 3nk. 3nk will be nothing but 3r if we are going to consider n equal to Avogadro's number. Okay, so this equation number 8 is exactly matched with the classical theory or the so-called Dulong-Petit's law, whatever they given by considering classical theory. You can check that Cv in the classical theory we found the same, that is 3nkb, right? 3nkb, and if we are going to consider n is the Avogadro number, then it will be 3r, and this is the this is r is constant. If we are going to consider r value, the Cv will be approximately 6 if we are going to consider classical theory. That means a constant value. There is no dependence of the temperature. Remember, it is very important. If we are going to consider classical theory, the Cv, specific heat of a crystal, is independent of temperature. There is no dependent of temperature. That means this type of things. This type of things means 3r means 6 if we are going to take Cv along y-axis and T along x-axis, and we found according to classical theory it has to be 6. But if we are going to consider different material, it is increasing, or we can say with decreasing of temperature this is decreases. Okay, but higher temperature more than 300 Kelvin, it is matched with 6. But below 300 Kelvin, it is decreasing. It is decreasing. Why it is decreasing? The classical theory could not explain. So the Einstein theory is modified version of classical theory. Einstein theory, some extent, he has been that model or Einstein model explained up to some extent. Up to what extent, that we are going to discuss. But Einstein theory not fully explained at very low temperature, means why it is decreasing. Einstein theory explained, okay, but at low temperature the behavior of increasing is one type of TQ. That means CV is behavior is approximately belongs to TQ, is proportional to TQ type, TQ types, it is increasing. But Einstein theory told that this increasing is one type of exponential. But actually, if we are going to consider experimental data, it is increasing as TQ. Okay, CV is proportional to TQ, but Einstein told that, or Einstein model told that CV is proportional to a exponential function, exponentially increasing, but actually it is increasing in the form of TQ. So why it is and how it is, that is again modified by Debye, that we are going to be discussing in our next class. But Einstein, what he done, that lower temperature behavior means it is decreasing with decrease of temperature, that Einstein theory explained, that we are going to discuss today, or we are discussing now. So at higher temperature, we found what we found. At higher temperature, by considering Einstein model, we found CV also equal to 3R, which is matched with Dulong-Petit's law as they obtained by classical theory. Okay, now we are going to consider lower temperature behavior. That means at lower temperature, why the specific heat is going to be decreased with a decrease of temperature, that could not be able to explain by classical theory, that is explained by the Einstein theory. Okay, not exactly, but it is explained. How it is, you just watch. For low temperature, such that KBT is less than that of the H cross. Okay, that means if we are going to consider KBT, that means T, here we are considering actually this factor theta E by T. So here T is less than that of the theta E. So here if T is less than that of the theta E, that means theta is nothing but H cross omega by KB, right? So automatically KBT will be less than that of the H cross omega 0, or you can say T is less than that of the theta E. So we can write that e to the power H cross omega 0 by KBT minus 1. If we are going to consider this factor, then if KBT is very less as compared with H cross omega, or H cross omega 0, H cross omega 0 is greater than that of the KBT, so this value, this exponent value is much larger than that of the 1. So 1 can be neglected, so approximately we can write this much value will be this much. Now from the equation number 3, that is belongs to average energy of the oscillator, if we are going to consider, this will be modified as only this much. One term is not going to be considered, it will be neglected if we are going to consider H cross omega 0 will be greater than that of the KBT. That means at very low temperature, right? So for equation number 3, we are going to consider this much: half H cross omega 0 plus H cross omega 0 by exponent of H cross omega 0 by KBT. 1 not to be considered. So what we are going to write? So then if this will be exponent to the power, in denominator it will be exponent to the power exponent of H cross omega 0 by KBT. Then if we are going to take it to the numerator, it will be exponent of minus H cross omega 0 by KBT, that I have been written over here. The average mean energy from equation number 3, we found that half H cross omega 0 plus half plus H cross omega 0 into e to the power minus H cross omega 0 by KT. Here I forgot to write B, you have to write, okay, kb here b is subscript. Okay, don't write in multiplication format, don't write like this k into b, it is not like, actually this is k subscript of b. Wherever I written kb, it always b is at the subscript. So this is equation number 9. From equation number 9 it can be perceived, one can be easily perceived that the average vibrational energy decreases exponential with decrease of temperature. So Einstein somewhat succeeded, or Einstein succeeded to explain why with decrease of energy the Cv has to be decreased. Here vibrational energy is decreasing, means the so called Cv also will be decreased, because vibration Cv is proportional to with the vibrational energy. We have been discussed in our first class itself of this topic. Okay, so we found Cv. Now from equation number 5 what we are going to consider, then Cv will be how much? See, instead of this one we are going to be considered this one for equation number 5. You can check the equation number 5 is this one. So in this equation number 5, this expression is going to be considered as only this much square, okay. So this will be got cancelled, like that we are going to, so Cv will be 3n kb into h cross omega 0 by kbt square into exponent of h cross omega 0 kb by kbt divided by exponent of h cross omega 0 by kbt whole square. So this one term can be cancelled out, and we are going to get Cv equal to 3n kb h cross omega 0 square by kbt, sorry, h cross omega 0 by kbt square into e to the power minus h cross omega 0 by kt. Okay, because after cancelling one term will be remain at the denominator. Okay, so as one term will be at the denominator, then it will be written as minus h cross omega 0 by kbt. Always write in the kbt. Okay, kbt, let it is equation number 10. Now Cv will be written in the form of, we know that h cross omega 0 by kb is nothing but theta e, that is characteristic temperature or Einstein's temperature. So it can be represented by this equation number 10, can be represented by this one by writing instead of h cross omega 0 by kb as theta e. So it will be 3n kb into theta e by t whole square into e to the power minus theta e by t. Okay, by substituting this one. Now if we are going to consider the molar specific heat, that means if we are going to consider n equal to Na, Avogadro's number, then it can be written as 3Na kb into theta e by t square into e to the power minus theta e by kt. Okay, so let these two equations are named as equation number 11. From equation number 11 we can get the low temperature behavior easily. Okay, so now we got the two equations by considering Einstein's model. One is number 8, at higher temperature the Cv behavior, and at lower temperature the Cv behavior is represented by equation number 11. So here you can see that at higher temperature this value is exactly matched with our classical model. That means at higher temperature this value is 3R, or we can say approximately 6. If we are going to consider molar specific heat, it will be approximately 6. Means if we are going to consider the Cv and corresponding temperature, at higher temperature this is 6, or some books it is written in the form of 3 nkb or 3R. Okay, so at higher temperature it will be match. This is the example actually. this curve is a representation of a crystal, that is diamond. This is the representation data of a diamond. So from this graph we can found that at higher temperature, so along x-axis we taken as t by theta e, and along y-axis we taken as Cv. So at higher temperature means if we are going to increase the temperature, at higher temperature it is matched with 6. It is approaches to this 6. That means at higher temperature the Einstein model is equivalent to the classical model result. Whatever the classical model given the result, it is matched with the Einstein model at higher temperature. but we found at that time that classical model could not explain that with decrease of temperature why the specific heat is going to be decreased. Here you can see that Einstein model is able to explain why it has to be decreased by considering the Einstein assumptions and whatever we discussed in our last two videos. Okay, here we can found that 1 e to exponent to the power minus theta e term is there, right? Exponent to the power minus theta e. Okay, so whenever we are going to so due to this factor we can say that Cv is decreases with decreasing of temperature, okay, that I am going to be explain here. You just watch carefully. See here, along x-axis we have been considered T by theta e. Here exponent to the power minus theta e by T, whatever may be, but you can check. See, that means here if we are going to decrease the temperature, this specific heat is going to be decreased. Okay, you just check it. See, now you can say that with decrease of temperature this factor is increases. That means these two factor is coupled with each other. But at low temperature this factor is dominating over this one. So we can say due to this factor the Cv is decreases at the low temperature. What Einstein able to explain. Okay, but exponential it is decreases. With the as per the Einstein's model. Here you can see whenever we are going to decrease temperature, you can see this is the factor, no, this is the factor e to the power minus theta e by t. That is nothing but 1 by e to the power theta e by t. Okay, so here if t is going to be decreased, then this term that is nothing but theta e by t is going to be increased, right? And I already told that theta e is a constant for a particular material. I already told to you. So as t is decreases, e to the power minus theta e by t, you just watch it, e to the power minus theta e by t can be written as 1 by e to the power theta e by t. So here t decreases, that means this factor will be increases. If this factor will be increases, that means whole this denominator factor, that is e to the power theta e by t, will be increased. If this will be increased, this whole will be decreased. So when theta will be decreased, then this one that is exponent to the power minus theta e by t is going to be decreased. Okay, so in this way or with the help of this expression, Einstein suggests that with decrease of temperature that specific heat is decreasing. Okay, but exponentially. But actually if we are going to consider the so-called these are the experimental data. These circular mark are the experimental data. This curve is the theoretical data what is predicted by the Einstein. Theoretical curve by Einstein. Okay, but this circular marks are experimental data. This circular mark told that Cv is proportional to TQ. That means Cv increases with TQ and Cv decreases with TQ. That means with the variation of TQ it is increasing and decreasing at the lower temperature Cv for the crystalline materials. But Einstein told that it is decreases with decreasing of temperature exponentially. That is contradicted. That means there is the lacuna we found in the case of Einstein theory, which is further modified by Debye. Okay, so these things I have been written over here, this much. I am just reading, you just watch it. See, from equation number 11 it can be observed that as T less than that of the theta, heat capacity Cb is proportional to this much, which is dominating factor. This is a dominating factor. Okay, due to this dominating factor, as T decreases, this CV is also decreases exponentially. From figure 1 shows the CV versus T by theta E for diamond using, I told no, that theta E is a constant for a material. For the diamond, this one is the value, theta is 1320 Kelvin. From figure 1 it is found that from figure 1 it is found that the theoretical curve well fitted or matched with experimental data over a wide range of temperature. Wide range of temperature means at the higher temperature, means from the higher temperature to the lower temperature, up to low temperature it is matched, but at very low temperature it fails over a wide range of temperature, but fails at very low temperature. That means around at 4 to 10 degree Kelvin it fails. Here at 4 to 10 degree Kelvin means very low temperature, the CV is increases or decreases, which is proportional to with TQ, not exponentially. So it is observed that most of the solid follow CV versus TQ law. TQ law, TQ law. Observed it follow most of the solids follows CV versus TQ law. You have to write law at low temperature region. So here Einstein fails to explain why it is CV varies with temperature as proportional with TQ. How it is, why it is, Einstein could not able to explain. Okay, Einstein explained that with decrease of temperature CV is decreases, that he explained, but at very low temperature why the CV varies with TQ, not exponentially, he not able to explain. So that is modified further by Debye. How it is modified, or what he considered? He considered that the oscillators, whatever we considered, or whatever classical and Einstein, both classical way means Dulong-Pettit and Einstein both have considered. They have been considered. Einstein and Dulong-Pettit means classical. They have been considered. Suppose this is our crystal, three-dimensional crystal. They have been considered that the atoms, whatever the present, they have identical, and they are oscillating with their own frequency, and both have the same frequency, that is omega 0, and that vibration is not interacted with each other, means freely they are vibrating. So according to classical and Einstein, they suggested that these atoms which are inside the crystal, these are the atoms, they are vibrates freely, or we can say independently. There is no interaction, but actually you can just recall your one-dimensional harmonic oscillator and two-dimensional monoatomic one-dimensional harmonic oscillator. Here I am going to show you the picture. This is your picture. Wait 1 second. Either you can consider monoatomic lattice is attached with a massless spring, means the model is, if this will vibrate, it is affects on this one, so that only we considered. If this will be displaced, all the atoms also displaced along with that atom. And also in your two, that is your what is diatomic diatomic lattice, also same thing. That means actually in the crystal, all the atoms, they are combined with each other, at least with the bonds, with the covalent bonds, they are combined with each other. So if one atom is going to vibrate, another, how it is not going to be affected. So if one atom is going to be starts vibrate, this vibration affects to the nearby atoms. So due to this is going to vibrate, due to this nearby atom is going to vibrate. That means we can say that the vibration is coupled with each other. The vibrations are coupled with each other. So this things or this model has been considered by Debye for further development of the model to explain CV versus T, and he successfully solved this problem, that why with decrease of temperature at very low temperature it has to follow this law. And due to his namesake, this is also called as a Debye model or CV versus TQ law, like that. So that we are going to discuss in our next class. Up to this much we have been completed your Einstein theorem specific heat. Go for this video and watch carefully, and whatever I am saying extra things you have to listen carefully, and write down the note by pause the video, and if any doubt you can ask to me. We are going to be discuss further. So thank you so much for watching this video, and wherever I not corrected anything today, okay, so here somewhere I written kb, you have to write there in your note, okay. So thank you so much for watching this video. Thank you.